Good evening, everyone, and welcome to our Astronomy 102 vodcast series, May Day Special. My name is Jyh Harng, and operating a telescope behind the scenes, we have Li Fei. We are both science educators from Science Centre Singapore, and today we'll be doing a short introduction of this celestial body closest to us, or our planet, the Earth, and that is none other than the Moon. Now, I mentioned the telescope that is being operated by my colleague Li Fei, but unfortunately tonight's weather is really poor. It's very cloudy, as you might have already experienced the thundery storms and showers in the late afternoon. So instead of a telescopic view or telescopic feed, right? So what we have is that Li Fei has actually helped us set up a virtual night sky using a software called Starry Night. Now, this virtual night sky software, right? Some people may also call it a planetarium software, but what it does is that it actually simulates a virtual night sky for us. And right now on the screen, you'll be seeing this virtual night sky. It might be not very visible or might not be very clear, but you should be able to see some stars. And also, the main character for tonight's special, the moon. Now, it's a bit hard to point out where the moon is right on the screen, right? But in a while, Li Fei will actually help us point out where the moon is, and the software can actually help us get a telescopic view of the moon. Now we can see that the moon, right, is actually being labeled right now. Now, don't worry if you see that the font is a bit small. In a while, Li Fei will actually zoom in there. All right, so the moon, right, this is how it would look like tonight if the sky was clear. Now, what happened is that, right, one of the first questions that people always ask about the moon is that, how is the moon formed? So, very interestingly, this is a question that is still an ongoing debate in the scientific community. But there are a number of theories that can help explain, right, the formation of the moon, right, as the moon of our planet. So what happens is that one of the first theory that was proposed was that the moon actually used to be part of Earth. So early in the formation of Earth, right, and the early stages when the solar system was formed, so as the Earth was being formed as well, it was spinning very fast. So one part of the Earth, which where the Pacific Ocean was, right, actually got thrown out, okay, as the Earth was spinning, and as a result of this big chunk of rock that was being thrown out, right, it actually became orbiting satellite around the Earth, right, or a natural satellite, and this became the moon as we know now. Okay, but however, this theory it's not very widely supported, and there are evidence to support that this might not be the best theory to explain the formation of the moon. So another theory that could help explain is that the moon perhaps might be another object that came into the solar system. So it could be a very big chunk of rock, or maybe like a very big asteroid that's outside the solar system, but it came to the solar system and it got captured by Earth's gravity and it started rotating or orbiting right around Earth. Now, we also know that this theory, it might not be very strongly supported because of the fact that it is very difficult, right, for an object this size to be captured by Earth, given that in the early days of the solar system formation, it's very chaotic. There's also a lot of other bigger planets. So this might not be the best theory of all. So there is another theory that is so far the most so arguably supported theory, and that is what it explains is that it may be that in the past and also in the early days of the solar system formation, as the Earth was being formed, a very big object, right, maybe the size of Mars, right, actually came and flew close by Earth and actually collided off axis or maybe at an angle. And as a result of this collision between this very large size object, Earth-sized object, and a Mars-sized object, right, a lot of the impact, or rather the impact, actually caused a big chunk of the rock, right, or parts of the Earth, and also this incoming body, right, to actually get dislocated, and also it just starts spinning or orbiting around the Earth, and as a result, form the moon that we know now. Okay, but what happens is that, right, these theories, right? So it's still an ongoing debate, and scientists are still currently trying to find out what might be the actual case on how the moon is formed. But so much for that for now on how the moon is formed. Let's take a closer look at the moon. So the moon right now, for tonight, if you are able to see it, okay, is actually in a phase which is called the first quarter, right? Or some people might call it a half moon, right? But what happened is that, okay, this moon, it's all right, the phases, okay, will change night by night, and we'll actually discuss that a bit later throughout for today's podcast. Now, let's take a closer look at the moon right now first, okay? And this is like a telescopic view of the moon already, okay? And every time you look at the moon, you will actually see certain features, okay? You see craters, you see patches of it where it's more gray in color, or what say more brighter, and also parts where it's more dark gray in color. Okay, so what happens is that these areas which is darker, okay, we actually call them Maria. So Maria is actually the Latin word for seas. Now, when we say seas, right, it's not actual seas that we have on Earth, but instead, right, people or astronomers in the past, when they look at the moon, okay, they thought that the moon actually had seas, which was all these dark colored regions. But turns out, of course, as we know now, they are not. But the names stick on, and we call them Maria now. Maria is actually the plural form. The singular form would be actually Mare. So let's take a closer look at one of these very interesting Maria, or rather Mare, sorry, and it's called the Sea of Tranquility. Now, the Sea of Tranquility, it's very interesting. Why? Because it is the landing site of the Apollo 11 spacecraft. So you might have heard of the Apollo missions, right? The space mission that was done by NASA, right, in the 1960s, where they land the first man of the moon, right? And the particular mission, it's the Apollo 11 mission. So the Apollo 11 mission brought the first two men on the moon. If you didn't know, the first man is Neil Armstrong, which name might resound to you, and the second person is actually Buzz Aldrin. So they actually landed on this area called the Sea of Tranquility. Now, Li Fei has actually helped us to label the Sea of Tranquility and also the landing spot of the Apollo 11 spacecraft. It might seem a bit small, but you can try to make out. So the label slightly towards the bottom, that's actually labeling the Sea of Tranquility. This big patch here of this grayish part of the moon. Now, this Sea of Tranquility, while it might look a bit small in respect to the whole moon right now, but it's actually quite a big area. In fact, its diameter or average diameter across this mare is actually about 800 kilometers. So what happened is this mare, they are actually a more smoothed out area, and you can see that in fact there are less craters in the mare itself. So this is a very interesting phenomenon which we'll briefly discuss. But now the importance of this particular mare, or the Sea of Tranquility, to Apollo 11, okay, was that right when Apollo 11, the commander Neil Armstrong was trying to land this spacecraft, they had some issues where they were landing too fast and they were actually going off course. So if they follow on course, or rather follow the course of how the spacecraft was landing, right, it will reach an area which is more bouldery, means they're filled with obstacles, and it will be very difficult to land and can actually pose a danger to the crew. So instead, Neil Armstrong had to manually command the spacecraft and quickly find a landing spot, and that he actually chose the Sea of Tranquility, which is more flattened out and it's easier for him to land. And it actually helped in a sense, it helped the success of the Apollo 11 mission. And there you get the first man on the moon. So it's not just this mare that you see on the moon. Actually, the surface features of the moon is very dynamic. There's also craters, as I mentioned, but there's also things called mountain ranges and also valleys. So if you do not know what valleys are, right? So imagine a mountain range, meaning like a line of mountains on the left and the right. So in between, there's a region where it's more shallow, and that area which is more shallow is like a very big drain, and we actually call it the valley. And with a telescope, you can actually make out some of these interesting features. So Li Fei, I think she will actually help me point out this particular mountain range, which is called the Monte Taurus, or the Taurus mountain range on the moon. Now, why am I pointing out this particular mountain range? Right, because this is actually a region, right, in which one of the other Apollo mission also landed on, and that is actually the Apollo 17 mission. So if you didn't know, right, it's not just Apollo 11 that landed on the moon, right? The subsequent missions 11, 12, 14, 15, 16, and also 17, they also managed to land on the moon at different spots. Okay, but for tonight's moon, as we know, it's actually the first quarter. Not all parts of the moon are actually illuminated by sun. So these are a few parts that we are able to show using the Starry Night software for now. So as I mentioned, the Montes Taurus or the Taurus mountain region is where Apollo 17 landed. Okay, and this particular interesting feature, right, is where there are a lot of mountain ranges and also valleys. And then the astronauts, when they landed there, they actually collected samples. In fact, not just for this mission, but also for the previous mission. And they actually get all these rock samples and they'll bring it back to Earth, where scientists can then study the soil of the moon. And from there, they can actually try to understand, right, the formation or the history of the formation of the moon, which actually helps in supporting the theories that we mentioned earlier for the formation of the moon. Okay, so we have talked about some of the features, including craters, valleys, mountain ranges, and also this very interesting Maria. Okay, but we did also mention that Maria is also darker in color. So let me just quickly address this right now. So what happened is that the Maria, their soil composition, right, is slightly different. They are more iron rich, meaning the soil is filled with more iron. And as a result of that, they actually looks darker because they reflect light lesser as compared to the surrounding regions. Uh, and also why is it that there's less craters? Why? Well, because it was proposed as a theory, also as a very good explanation, that perhaps in the early days when the moon was formed, right, there are actually volcanic activity. So what happened is that when planets are being formed in early stages, you can imagine them like very uh, uh, big and very hot, melting kind of like balls of rocks. So the moon was something like this as well, and it was actually volcanically active. Now, I'm not suggesting that there are actual volcanoes. There are some evidence to support that could be volcanoes in the past on the moon. But what happened is that these Maria regions is where perhaps the crust was actually more thinner, and as a result, lava below the ground or below the crust of the moon actually can flow out as lava, right? Right. So magma below there's actually magma in the past, perhaps, right, that flows out on the surface, okay, as lava, and it covered a big region, right, with this iron-rich lava, and as it cool down, it becomes the Maria as we see now. And what happened is that, so after all this lava cools down, right, it covered all these craters, and as a result, you don't see that much craters on this region where the Maria is, right? But there are still some craters which will be formed by space rocks or asteroids that collided on the moon's surface. Right. So we have looked at a few features of, or rather the more important features of the moon already. So let's now also so let's now continue to look about the other side of the moon, okay, which the software can actually help us do, right? But what do I mean by the other side of the moon? Okay, so now what happened is the moon itself, right? It's a ball, okay, it's a ball-sized or ball-shaped planet, right? And there is the side of the moon that's facing us and the side that is facing away from us. Okay, but what you might not have known is that the moon, right, actually face us, right, with the same face, okay, all the time. Okay, and we say that the moon and the earth are tidally locked, okay, meaning it is a phenomenon where as the moon orbits around the earth, it rotates at a rate similar to how the rate of the moon is going around the earth, and as a result, the same side of the moon keeps facing the earth. Now, what happens is that the side that faces us or faces the earth, we call it the near side, while the side that faces away from the earth, it's called the far side. Now, some of you might have heard that this far side is called the dark side of the moon. If you might have watched the movie Transformer Dark Side of the Moon, right, it is not exactly the case to call the far side the dark side. Why? Because what happened is that, okay, as the earth and the moon move around or orbit around the sun, right, what happens is that different parts of the moon gets illuminated by the sun. Okay, the side of the moon that faces the sun, okay, will be illuminated by sunlight and it will be bright. But what happens is that, okay, only the side of the moon that's facing us, okay, we'll get to see it. And as a result of this, we will actually get phases. So Li Fei has kindly helped us to show this particular scene, okay, to help us explain how phases of the moon comes about. So right now you can see that the moon, okay, it's somewhere to the left side of the screen. Okay, the sun is somewhere at the bottom, while the earth is at the center. So what happens is that the side of the moon that is facing the sun will get illuminated. And if you realize that side, okay, that we can see right now is actually the side that faces the earth, or the near side. And as the sun, or rather the moon, move or orbits around the earth, okay, different parts of the moon, okay, get exposed to the sunlight. And you can see as a result of that, okay, right now as the far side of the moon, okay, is facing the sun, the near side does not receive any sunlight, so it's dark. And this phase we call it the new moon phase. And as the moon continue to orbit, right, some parts of the near side of the moon, right, is illuminated by sunlight, and then we can see it. And this gives us the phases that we see, okay, every night. So tonight, as I mentioned, is the first quarter. Right, so right now I'll just let Li Fei play another round of animation to let you see how the phase of the moon change about. Okay, so now for those of you who've just joined us, okay, welcome to our May Day special. Okay, our topic for tonight is the moon. So we have been talking quite a lot about the moon already, but if you have any question, you can always go down to the link in the video description or in the pinned comment of our Facebook live video, and we'll try the best to answer your question. So right now, okay, if right now we don't have much questions, but you have any, just feel free to post out so that we can actually address it to you. Right, but if not, okay, what I'm going to do is I'll let Li Fei actually show you a closer look of the dark side of the moon. Right, because this is the side of the moon, right, that we actually don't see, as we call it the far side of the moon, right, which always faces away from us. So right now, Li Fei is showing you like a kind of like a 360 degrees view of the moon. So it's like imagining us as like in a rocket or a spaceship that is going around the moon. So right now we are approaching the far side of the moon. Now the far side of the moon will look very different from what you see on the near side of the moon. So you can see also the Earth is moving around. Okay, but the Earth is not actually orbiting around the moon, right? Just to disclaim, it's actually in fact the moon is actually orbiting around the Earth. So if you take a closer look on the dark side, or sorry, I'll correct myself again, the far side of the moon, there seems to be a lot more craters. And in fact, there is no visible Maria that we can see on the far side of the moon. So this is very interesting, and it brings about quite a few questions. So the first question, right, is that why is it that the far side of the moon has much more craters? Now, scientists also have different explanations for this. So the first explanation that scientists thought was that perhaps in the past, also in the early days of the solar system formation, because it's very chaotic, there's a lot of space rocks, a lot of asteroids and comets. So what happened is a lot of these asteroids and comets collided with a lot of the planets, and also including our moon, forming all these craters. Okay, but what happened is the moon on the near side had some shooting effect from Earth, as the near side of the moon is always facing the Earth. So as a result, the far side gets bombarded by the asteroids more frequently, resulting in more of these craters. But what happened is scientists, as they study and investigate this theory, they realize it is not very plausible because of the distance between the Earth and the moon. It's rather significant, it's actually quite far apart, and the shooting effect will not be that significant to explain the difference in the amount of craters between the far side and the near side of the moon. So instead, another theory was proposed, and that theory is that the near side of the moon perhaps had a slightly thinner crust or a thinner surface, and the lava beneath the crust, as I mentioned earlier, perhaps is easier to flow out or just erupt from the surface, and as a result, it covered up the initial phase of bombardment that created all these craters on both sides of the moon, and then later, as all this lava erupts and flows out and cover the craters, okay, it actually covered most of these craters on the near side. And as the time passed, as not too much, or rather as the solar system formation gets more peaceful, right? So that we have less of this asteroid bombarding on the moon, resulting in the case where the near side of the moon, right, has more of this maria and it's more smoothed out compared to the far side. Okay, now let's see if you have any questions. Okay, we have one very interesting question, which is, okay, what happens when the sun, the moon, and Earth are all in the same line? Okay, this is very interesting question, and actually can help us lead to this very interesting phenomenon that we can actually discuss, and that is actually the eclipse. Now, when we talk about eclipse, there are two main types of eclipse that we usually will hear or even observe. So, just last year, December 26th, right, you might have heard of the solar eclipse, right, or the annular solar eclipse, to be more specific. All right, not just solar eclipse, there's also the lunar eclipse. So what happened is, right, when the Earth, the Moon, and the Sun aligned, right, they can actually form these two eclipses. Okay. Now, I have a colleague who actually helped me summarize this. So what happened is that when you have the three bodies aligned such that it's the Earth, right, the Moon, then the Sun. Okay, try to imagine this. Okay, then you get a solar eclipse. Okay, I repeat again, the Earth, followed by the Moon, then the Sun. All right, so in that case, the shadow cast by the Moon, okay, lands on Earth in a very small little cone or a little area, and people in the area in the shadow cone, right, will experience a lunar eclipse, sorry, a solar eclipse, right, and that is why a solar eclipse can form, because basically the Moon comes in between the Earth and the Sun, okay, and the shadow of the Moon, right, causes a solar eclipse. So right now, you can see that on the screen that Li Fei is actually showing, right? This is actually, I believe, a lunar eclipse. So what happens, you can see that the Earth is behind, okay, and the Moon is at the front or at the foreground, and actually it casts a shadow towards Earth. Right? So this is a solar eclipse. Now, in the other case, okay, what you can get is that, right, you have the Moon followed by the Earth, then the Sun. Okay, try imagining this again. The Moon, the Earth, then the Sun. Right? Then this is a lunar eclipse. Okay, why? Because now the Earth is in between the Moon and the Sun. And as a result, okay, the Earth casts a shadow on the Moon. Oh, actually, I think my apologies. So actually, the simulation earlier, okay, that's done by Li Fei, actually shows a lunar eclipse. All right, so please pardon me. Now, so let's just use the simulation now to explain the lunar eclipse, which we are mentioning. So the lunar eclipse happens when the Earth is in between the Moon and the Sun. So what happens is the sunlight, okay, goes through Earth. Sorry, not goes through Earth, right? I apologize. That's not a correct term to use. What happens is that the Earth actually kind of blocks out the sunlight that's reaching the Moon. Okay, so the Earth shadow gets cast on the Moon, and as a result, the near side of the Moon, okay, has this shadow that's cast on it. Usually, it looks red, right, because of this scattering phenomenon where light of different colors bend differently, and the atmosphere of the Earth, right, actually cause more red light to go towards, right, around towards the Moon. So as a result of that, okay, the Moon will appear red usually during a lunar eclipse. Okay, so this is lunar eclipse when the Earth's shadow, okay, is cast on the Moon. So remember this, if you have a sequence in which it's the Moon, Earth, and Sun, right, you get a lunar eclipse. Okay, whereas if you get Earth, a Moon in between, then the Sun, okay, then you get a solar eclipse. Okay, how about in a case where you get a Earth, then a Sun, and a Moon? Okay, that's not an eclipse. That is an apocalypse, right? An apocalypse, right? Which should not happen. Okay, which should not happen, right? So there's just a little thing for you to take back, right? If it's Earth, Sun, and the Moon, right, then that's a apocalypse. right? So shout out to my colleagues. I think they will actually get this. All right. So now, if you for those who just tune in to the vodcast, all right, we're actually talking about the moon. Okay, we have described quite a little bit about the moon already, about its features that you can see through a telescope, including craters, including the mountain ranges, and also the Marias. Okay, and also we talk about moon phases and also the eclipse. But if you have any questions, okay, you can always feel free to post them, and the link that was displayed in the video description and also in the pinned comment of the comment section in the live video. Okay, so now I'll just leave it to you to take a good look on the moon when it's actually in the full moon phase. All right, so this is the full moon, as you can see in the screen right now. So take a look. You can see there's a lot of craters. Okay, also you can see there's a lot of these dark regions, which we call the Marias. All right, let's see. Oh, now see, Li Fei is actually helping us to label out the very interesting features of the moon. Let's see if we can see some of the more interesting one. Okay, all right. Since we actually mentioned about the Apollo missions, right? So Li Fei actually helped us to label out all the landing sites for the different Apollo missions that managed to land on the moon. Okay, as the font is a bit small, so I think Li Fei is actually trying to help us zoom in so they can have a clearer view. Now, a quick fun fact is that okay, it takes about 3 days okay, for each of the Apollo missions, okay, or at least on the Apollo 11 mission, okay, for the spacecraft to reach from the Earth to the moon. And it took, I think, then just about a day for them to actually do the experiments and also for the exploration of the moon for the Apollo 11 crew members that landed on the moon, right? And then another 3 days for the whole crew to come back to Earth. Okay, and another small fun fact, which is there were actually 3 crew. Okay, in fact, all the Apollo missions, if I'm not wrong, okay, they have 3 crews. Okay, but for Apollo 11 mission and also likewise for the other missions, the 3 crews, okay, they'll be actually split according like this. So one person will remain in a module that is actually orbiting or remains in orbit around the moon. Okay, and this is what we call the command service module. Okay, whereas the other module, right, it is the module that will land on the moon specifically, and that module we call it the lunar module, and that module for the Apollo mission had a very interesting name. They call it the Eagle. So if you want, or if you're interested, you can always go back to YouTube or just Google Apollo 11 landing video, so you can actually hear Neil Armstrong as he tries to land the Eagle on the moon. Okay, it's a very tense moment where Neil Armstrong had to last minute try to find a way to quickly land the module, right, or the Eagle on a Sea of Tranquility. Okay, in fact, when they landed, it was estimated they only have about 45 seconds of fuel left. Okay, I can imagine how tense the situation could be. Now, we also mentioned that there's this module left orbiting around the moon. So if you didn't know, for Apollo 11 mission, there was also another astronaut, okay, that actually followed Apollo 11, but he didn't actually is named Michael Collins. So you can actually check that out, right? I believe his role in the mission is also very critical, although he did not get the glory as the first person or second person to actually step foot on the moon, but he actually played a very crucial role. All right, let's see. Okay, the time now. All right, okay, the time now is really 8:29. I think it's about time that we should kind of wrap up tonight's special, May Day special, and that you can have an early rest and have a long weekend. So what I'm going to do is I will let Li Fei, okay, how I say one final goodbye to the moon. One of the most interesting night sky objects that we have on a nightly basis. Okay, but it is about time when we say goodbye to the moon. All right, goodbye, moon. With that, we have come to the end for tonight's podcast. Once again, my name is Jyh Harng, and my colleague Li Fei controlling the software that you have been seeing throughout tonight's podcast. And behind the scenes, we also have a few very hardworking colleagues, and there is Ferry, who is controlling the streaming, and also there are Octave and Kang Hui, who are trying to answer some of the questions that you might have. So With that, I hope you enjoy the session. But remember to stay home, stay safe, and as always, keep looking up. All right, Jyh Harng signing off.